Bismillahirrahmanirrahim. Let's talk about some of the examples of use of biotechnology in textile industry. Textile industry is perhaps one of the biggest industry which is using so many different enzymes from different microorganisms to achieve different industrial processes. Now, it has been long known that the use of different enzymes to either treat different fibers or textile goods or to manufacture them as well. For example, you can see here amylase enzymes from malt extract have been known to be used to degrade starch-based sizes for cheap and effective reduction of fabric stiffness and improvement to its drape. जो साइजिंग होती है फैब्रिक्स की और स्पेशली जो स्टार्च बेस्ड साइजिंग है उसमें अमाइलेज एंजाइम बहुत यूज़ हो रहा है. सो ऑब्वियसली अमाइलेज क्या करता है, स्टार्च के ब्रेक डाउन करता है. सो दैट मेक्स इट ईजी to operate this sizing process at much low cost by using enzyme, especially amylase enzyme. Currently, novel enzymatic methods provide a fast and inexpensive alternative to traditional flax extraction by breaking down the woody material in flax straw. Flax जो है is basically a plant, एक crop के तौर पे भी यूज़ होता है ये. So इससे extract करके भी textile बनता है, different किस्म के drapes और cloths बनते हैं, especially लिनन जो है वो इससे बनता है. सो इससे जो हम अचीव करना चाह रहे हैं फ्लैक्स स्ट्रॉ, और उसको भी ऑब्वियसली कन्वेंशनली ही यूज़ किया जाता है, कन्वेंशनली उसे ड्राइव किया जाता है, बट इट कैन बी आल्सो अचीव्ड इफ़ यू यूज़ डिफरेंट टाइप्स ऑफ माइक्रोब्स एज वेल, एंड ऑब्वियसली दैट रिड्यूसेस द कॉस्ट एज वेल. सो यू कैन सी हियर enzymatic methods are also being used alternative to the traditional flax extraction by breaking down the woody material in flax straw, reducing the process time from 7 to 10 days down to matter of hours. So जब enzymatic reaction use किया जाता है to derive these flax materials, so it reduces not only the cost but it also reduces the time as well. You can see here कि conventional method जो है वो 7 से 10 दिन लेता है, लेकिन if we use these enzymes, so it can be a matter of hours. So these extraction from flax, it is basically used to make different cloths, especially linen. The enzyme-based treating processes available for use on hemp and flax procedure, they produce finer products, cleaner fibers, and consequently novel processing techniques are being developed to take advantage of this. हमने पहले भी जिक्र किया था कि जब भी बायोटेक्नोलॉजिकल अप्रोचेस यूज़ करते हैं, ऑब्वियसली ज़्यादातर उसमें हम एंजाइम्स यूज़ करते हैं. जब भी हम एंजाइम्स यूज़ करते हैं इन एनी इंडस्ट्रियल प्रोसेस एज़ कम्पेयर टू कन्वेंशनल इंडस्ट्रियल प्रोसेस, तो इससे ना सिर्फ कॉस्ट कम हो जाती है बल्कि प्रोडक्ट जो बनती है वो भी फाइनर होती है और उसकी एफिशिएंसी भी ज़्यादा होती है और लेस टाइम में बनती है. एफिशिएंसी भी ज़्यादा होती है. ऑब्वियसली एंजाइम्स आर नेचुरल बायोकैटलिस्ट एंड एज दे आर नेचुरल दे कैन परफॉर्म सर्टन केमिकल रिएक्शंस इन अ मच मोर एफिशिएंट वे as compared to the conventional industrial reactions going on. Now, interest is growing in the production of new biodegradable polymeric fibers which can be synthesized using modified soil bacteria. ना सिर्फ already textile बन रहा है, ना सिर्फ fabrics already बन रहे हैं from already available resources, but now interest is कि हम fabrics को bacteria के ही through बनाएं all and all. So that would be much more of interest, and that may have much more impact on economy. Now this can be done avoiding the current persistence of these materials in landfills long after garments made from them are worn out. तो ज़्यादा इंटरेस्ट क्या है कि बैक्टीरिया से ऐसे बनाई जाएं फैब्रिक्स वगैरह और उससे रिलेटेड कंपाउंड्स जो कि बायोडिग्रेडेबल हों. इससे क्या होगा कि वंस यू हैव worn out some cloth and you can if you want to throw it out in the environment, तो वहाँ पे उसकी persistence इतनी ज़्यादा नहीं होगी, that could be easily biodegraded. So basically again you can see here it will be much more eco-friendly. In natural fiber production, enzymes are useful to remove the lubricants which are introduced to prevent snagging and reduce thread breaking during spinning, and to clean the natural sticky secretions present on the skin. बहुत सारे एंजाइम्स यूज़ होते हैं टू रिमूव डिफरेंट लुब्रिकेंट्स. जब भी इस तरह के फैब्रिक्स वगैरह बनते हैं तो उसमें लुब्रिकेंट्स यूज़ होते हैं इसलिए कि उसमें एक प्रोसेस फॉर एग्जांपल स्नैगिंग और इससे रिलेटेड प्रोसेस ना हो. ये बेसिकली क्या है, इट इज़ बेसिकली ब्रेकेज ऑफ थ्रेड बाय प्लकिंग और बाय पुलिंग. तो जब भी थ्रेडिंग होती है उसमें प्लकिंग और पुलिंग से स्नैगिंग का खतरा होता है, थ्रेड के ब्रेक का खतरा होता है, तो उसको मिनिमाइज करने के लिए डिफरेंट टाइप्स ऑफ लुब्रिकेंट्स यूज होते हैं. वंस द प्रोसेस इज कंप्लीट, we need to remove those lubricants, those greasy materials. So instead of removing those by using some other chemicals, it is best if we can use some enzymes that can remove those lubricants in a much more efficient manner, producing a much more quality product. So you can see here there are different enzymes which are being used to remove the lubricants as well, which themselves are used to prevent snagging. Now bioscouring is there as well for wool and cotton, and this process also uses enzymes to remove dirt, wax and fats, etc. Scouring basically क्या है, basically we want to remove any kind of dirt or any kind of wax or any type of fats found in the natural fibers. That can be done by conventional means as well, but again that can be done by using different enzymes as well, by using biotechnology. So you can see here bioscouring is being operated as well in the industrial sector, in the textile industry. Bio-bleaching. Bleaching, obviously we know bleaching is to remove color. There are so many natural colors which are present in the fibers and in the cloth which are made from these sources, and one may like to remove those natural colors and introduce a color of its own choice. So if you want to do that, we need to do bleaching process, and this bleaching process obviously can be done conventionally by using some other chemicals as well. But nowadays, bio-bleaching is being used. Basically, again, it uses enzymes that those enzymes can remove the color from these fibers, cloth fibers, so that one can introduce colors of its own choice. So bio-bleaching uses enzymes to fade materials, avoiding both the use of caustic agents and concomitant effluent treatment problems such as conventional methods entail. जब भी conventional methods यूज़ होते हैं bio-bleaching के, तो obviously उसमें बड़े caustic किस्म के compound यूज़ होते हैं, तो वो ना सिर्फ प्रोडक्ट की क्वालिटी भी कम कर सकते हैं, कॉस्ट भी इंक्रीज करते हैं, लेकिन दे आल्सो ऐड टू द एनवायरमेंटल पोल्यूशन. जो एफ्लुएंट रिलीज होगा इंडस्ट्री से, उसमें वो सारे कॉस्टिक एजेंट होंगे, और दोज आर ऑब्वियसली टॉक्सिक फॉर लाइफ and they can do much more damage to the living organisms present downstream. So if we do bio-bleaching by using enzymes, that can solve all these problems. Biological catalysts have also proved effective in shrink-proofing wool, improving quality while ameliorating the wastewater produced and reducing its treatment costs. कई टेक्सटाइल इंडस्ट्रीज में इस बात पर फोकस किया जाता है कि the cloth and the goods that they are manufacturing should be shrink proof, shrink ना हो वो after usage. So उसके लिए भी बहुत सारे इंडस्ट्री प्रोसेसेस हैं जो कि वो ऑपरेट करते हैं, बहुत सारे केमिकल्स वगैरह इंट्रोड्यूस करते हैं वो in the fabric to prevent shrinkage from happening. Again, that can be replaced with the enzymes and with microbes as well. So you can see here almost every step of textile industry has been replaced by biotechnology, by different enzymes from microorganisms. Biopolishing. Now polishing is also another step which occurs in the textile industry to produce textile goods. So instead of doing it conventionally by using different chemicals, now biopolishing is being done. Obviously that means that polishing is being done by using enzymes from microorganisms. क्या करते हैं ये? Biopolishing involves enzymes in shearing of cotton microfibers to improve the material's softness and the drape resistance to peeling of the eventual garments produced. Polishing बेसिक करती क्या है कि इसमें जो एक्स्ट्रा कॉटन फाइबर्स निकले हुए हैं क्लॉथ में से, उनको रिमूव करती है, उनको स्मूथ करती है क्लॉथ को. सो ये पॉलिश करना है बेसिकली. सो इंस्टेड ऑफ यूजिंग केमिकल्स टू पॉलिश द क्लॉथ्स, द फाइबर्स, the drapes, one could use enzymes to achieve the same results, but in a much more efficient manner, and the quality of the product will be high as well. Biostoning, as we know, what biostoning does is that it actually diminishes the color of the fabric giving it a worn out look, especially in denim jeans. So stoning is also done conventionally by using different types of chemicals, which again are harmful not only to the cloth itself, but to the environment as well. So stoning can also be done by using enzymes, which will be called biostoning. So biostoning has been widely adopted to produce stone-washed denim, with enzymes being used to fade the fabric rather than the original pumic stone method, which had a higher water consumption and caused abrasion of the denim. So जो conventional method है उसमें water consumption ज़्यादा है, abrasion भी होती है denim की, मतलब उसकी quality भी low हो जाती है. Obviously जो effluent release होगा उसमें भी वो सारे toxic compounds होंगे. So stoning has also been replaced by biostoning, that is the stoning using enzymes. Now, one of the most interesting examples of use of biotechnology in textile industry is the incorporation of adsorbers and microbes within a geotextile produced for use in land management around railways. ये टेक्सटाइल जो है रेलवेज के अराउंड यूज होता है लैंड को मैनेज करने के लिए, लैंड को प्रोटेक्ट करने के लिए. Soaking up and subsequently biodegrading diesel and grease, the textile directly reduces ground pollution, provides safer working condition and reduces risk of fire. So ये जियो टेक्सटाइल जो है जो कि बायोटेक्नोलॉजी के प्रोड्यूस हो रहा है, इसका फ़ायदा क्या है कि ये बायोडिग्रेडिंग डीजल जो है, जो डीजल है जो ओबियसली ट्रेन के इर्द गिर्द रिलीज होगा, और डीजल या इससे रिलेटेड जो चीज़ें जो पेट्रोलियम बेस्ड चीज़ें वहाँ पे कंपाउंड रिलीज होंगे ट्रेन ट्रैक के इर्द गिर्द और उससे एसोसिएटेड ट्रैक्स पे और जगहों पे, इफ़ दिस टेक्सटाइल इज बीइंग यूज्ड, it contains such substances, such microbes as well, and microbes related substances as well, which can degrade the diesel and associated related compounds, or therefore it reduces the ground pollution, and it is much more safer to work with this geotextile, and it also reduces the risk of fire. So you can see here the applications of biotechnology are enormous. And especially in case of just textile industry, there are so many horizons which can be explored, and there are so many things that can be achieved by using biotechnology. I will see you in next lessons.